This is November 2010 Modular paper, Unit 1, Statistics and Probability. Question 5 is a conversion question. It's going to ask you to convert between currency, which is money, and weight. So, Margaret is in Switzerland. The local supermarket sells boxes of Reblochon cheese. Each box of Reblochon cheese costs 3 francs 10 cents in Swiss francs. It weighs 160 grams. In England, a box of Reblochon cheese costs £13.55 per kilogram. The exchange rate is £1 is equal to 1.65 Swiss francs. Work out whether Reblochon cheese is better value for money in Switzerland or in England. So the first thing you need to do is convert, or well, the ultimate thing you need to do, I guess, is convert the money and the weights to be the same so that you can compare, because you can only compare things that are the same. So let's see. It's a comparison question, so I'm going to list my 2 items on each side of the page. Anything to do with the Swiss is over here, anything to do with England is over here. So we know that 160 grams of cheese in Switzerland costs 3 francs and 10 cents. And we know that in England, 1 kilogram costs £13.55. So you can make a decision whether you're going to convert the francs to pounds or pounds to francs. Now, because the conversion we've been given has the £1 equivalent to 1.65, that means it's easier to convert the pounds to francs because you just need to multiply by that scale factor, which is 1.65. So that then gives you the information that 1 kilogram is equal to, and let's do it on the calculator, £13.55 times by 1.65 equals SD. Now it's 22.3575. Money is written to 2 decimal places, so I know I need to cut it off there, and the 7 tells me to round the 5 up. So it's actually 22.36 Swiss francs. Okay? So that's what 1 kilogram of that cheese costs in francs if you were to buy it in England. Now what we need to do is get the Swiss conversion from grams up to 1 kilogram. Now it's quite difficult to go from 160 up to a kilogram, which is 1,000. Kilo is 1,000. So what I need to do is adopt a unitary method, and that is to find out first of all what 1 gram is equal to. And then once I know what 1 gram is equal to, I can times it by 1,000 to get up to kilograms. So on my calculator, I'm going to enter the amount 3.10 or 3.10. And in order to get it to 1 gram, I'm going to need to divide by 160, just as if you were solving an algebraic equation. So I got 3.10 divided by 160 equals 0.19 or 0.0193. And that goes on. Now I'm not going to round it or cut it off here because I might end up losing accuracy marks. So I'm going to leave that on my calculator display, because now I know I need to times it by 1,000. So I leave the answer there, I just press times by, and that takes the full answer and times it by 1,000. And that ends up giving me 1 kilogram, which is equal to 19.375. So we know that in Switzerland, 1 kilogram, and I need to round it there again, 1 kilogram costs 19 francs and 38 cents. And in England, if I was to buy it, it would cost me 22 francs and 36 cents. Therefore, you can clearly see that this, the Swiss the Swiss amount is the smallest, and therefore they want us to work out whether the cheese is the best value for money in Switzerland or England. So the cheese is better value in Switzerland than England, because 1 kilogram costs 19.38 francs in Switzerland compared to 1 kilogram, which is 22.36 francs in England. And for this, the mark scheme is divvied up as a method mark for showing that you're aware you need to convert from the 160 grams to get to the unit that you need. So by showing that you've managed to get from 160 grams to a kilogram is one method mark. The other method mark is for showing that you've been able to convert your money, your currency, from one region to another. It doesn't matter which way you've gone, you get the mark for converting the currency correctly. The next method mark is for putting them as a standard unit. So by making them both a kilogram, I get 1 mark for that. If I had chosen to make them both a gram to compare, I would get the method mark also. And the fourth and final mark is... Oh, I'm wrong there. You don't get a mark for that. You get an answer mark. Sorry. You get an answer mark for having the correct answers of the conversion, and you get the final communication mark at the end for making the statement based on what your answers show. So there's your 4 marks. Question 6 is one of those questions that give you a lot of information and you can end up getting quite messy in your workings out. In order to avoid this, you need to be confident in using and setting up what is called a two-way table. And a two-way table is when you have 2 variables and you need to lay them out in an ordered way. So this question's asking for 120 children went on a school's activities day. Some went bowling, some went to the cinema, the rest went skating. 66 of the children were girls. 28 of these 66 girls went bowling. 36 children went to the cinema. 20 of the children who went to the cinema were girls. 15 boys went skating. Work out the number of children who went bowling. So whatever I do at the end of this question, I need to work out the number of children that went bowling. Now the number of children, because it doesn't specify a gender, it means they want the boys and girls that went bowling. So at this point, I've actually forgotten about the big lists of information that they've told me about up here. I need to write some notes down. 120 children went on the activity day. Some went bowling, some went to the cinema, and some went skating. Bowling, cinema, skating. 66 of these children were girls. 28 girls went bowling, and then obviously if there's girls involved, then there's boys involved. So this is the beginning of my two-way table. This allows me to look at girls, boys, bowling, cinema, skating, and it allows me to deal with the totals. So now I'm going to put the information in from the question. So 120 children went on the activity day. So that means that the total of everything is going to be 120. Everybody that's involved is there, 120. 66, the children that went skating, so there's skating. 66 of the children were girls. So here's the girls. And 66 of them. So there's 66 girls. 28 of the 66 girls, so here's the 66 girls, 28 of them went bowling. 28 girls went bowling. 36 of the children went to the cinema, so that's both genders, and that's 36 went to the cinema. So there's the cinema, girls, boys, total. So there's 36 there. 20 of the children that went to the cinema were girls. So there's 20 girls there. And finally, 15 boys went skating. So there's boys that went skating, and there's 15 of them. Now, at this point, just by converting the question to a two-way table, I've gained a method mark. There's 1 mark. So, this is a 4-mark question. In order to get the second mark, I need to start working with the numbers I've got here to fill in some of the blanks. The first thing I'm going to do is work out how many boys there are altogether, because I'm interested in this particularly, the bowling. I need to aim to get this here complete, how many children went bowling. So let's look at the boys. There were 66 children altogether, 120 children altogether, 66 girls. So in order to find the number of boys that went bowling, I take the full 120 and I subtract the 66 girls. That leaves me with 54. So there were 54 boys on the trip. Finding that information gives me a method mark. So there's 54 boys. Now from that, I want to fill in this blank here. And this is the people that went to the cinema. There were 36 altogether. 20 of them were girls. That leaves you with 36 take away 20, which is 16 boys went to the cinema. Now what I can do is fill in this gap about the number of boys that went bowling. So there were 54 boys altogether. 54 boys altogether. Take away the 15 that went skating. Take away the 16 that went to the cinema is going to leave me with 23 boys went bowling. So there's 23 boys bowling. That now allows me to add up the girls that went bowling and the boys that went bowling, and it leaves me with the answer of 51. So the fact that I found out some more missing answers can give me a method mark. The fact that I'm going to now identify that 51 is the number of people that went bowling gives me the final answer mark. Question 7 is quite a complicated one to set out. A company sends every item of mail by second-class post. Each item of mail is either a letter or a packet. And there's the information we've got about letters, and there's the information we have about packets. The table shows information about the cost of sending a letter by second-class post and the cost of sending a packet by second-class post. The company sends 420 items by second-class post. So straight away I'm thinking of that as my total. There's 420 items altogether. The ratio of the number of letters to the number of packets was 5:2. Now ratio is always written in the order that they're given to you. So we were given letters first and then we were given packets. So my ratio is going to be letters to packets in the ratio of 5:2. So for every 5 letters that were sent, there were 2 packets sent. Then it goes on to tell us that 2/3 of the packets were in the weight range of 0 to 100. The other packets, so straight away I'm calling that 1/3, the other packets were in the weight range of 101 to 250 grams. Work out the total cost of sending the 420 items by second-class post. Right, first thing I need to do is work out, of that 420 total, how many of them were letters and how many of them were packets. So in order to do that, I need to find the total amount of parts, which is 7, because I've added them together. So there's 7 parts in total, and that 7 parts represents the 420 letters. So in order to find what one part is worth, I do my 420 divided by 7, which tells me that one part is worth 60 items. So the fact that 5 parts are letters means 5 lots of 60 are letters and 2 lots of 60 are parcels. Therefore, we end up with 300 letters to 120 parcels or packets. Now I need to move on to looking at the cost. And I'm going to do the letters first because it's really easy. So the cost of my letters is that there's 300 letters times by however much one letter is. And here's my letters, and it's 32p. Now, because my answer is going to be in pounds and pence, I'm going to try and always enter money as it would be written, like that. So I'm going to do 300 times by 0.32. So 300 times by 0.32 equals £96. So I'm spending £96 on letters. Now I can move on to my packets. Again, look at how I'm splitting this working up so it's easy for the examiner to follow. Packets. I've got 2 different types of packets. I've got the ones that are in the range of 0 to 100 grams. And I've got the ones in the range of 101 to 250 grams. So I'm going to separate this part of my working up into those 2 quantities. Now the question told me that 2/3 of the packets are 0 to 100. So I've got 2/3 there of the total amount of packets, which was 120. And the remaining 1/3 of the 120 were in the range of 101 to 250 grams. So in order to find any fraction of an amount, you need to get one of those quantities first. So I'm going to look for finding the third, 1/3 of 120. Now, in order to find a third of something, you divide by the denominator. So I'm going to do 120 divided by 3, which is 40. Now, if the numerator, the top number of a fraction, is greater than 1, then you would multiply by that. But in our case, it's only 1/3. Therefore, there are 40 parcels or packets that are within that weight range. So let's look at this now then. There are 2/3. I've already found that 1/3 is equal to 40 packets. So 2/3 is going to be 2 lots of that, which is 80. So I've got 80 packets within that range and 40 packets within that range. Now let's look at the price. In the 0 to 100 range, I've got 80 packets that cost, up here, 0 to 100, £1.17 each. So I've got 80 times by £1.17, and that's going to give me £93. And the calculator will say 93.6, but you need to remember we're working with money, so it's £93.60. And then I'm going to look at my weight range of 101 to 250 grams. There were 40 packets multiplied by £1.51. And when you put that in your calculator, you end up with £60. And it says 0.4, but we're dealing with money, so that means in 40 pence. Now I can go ahead and find my total cost. And my total cost is going to be my £96, add my £93.60, add my £60 and 40 pence. Notice how my decimal point is in line throughout this addition, which prevents me from making any mistakes. So when I add that up, that's 0, 6 and 4 is 10, 0 down, carry the 1, decimal goes under my decimal. 6 and 3 is 9, and the 1 is 10, 0 down, carry the 1, 9, 9 and 6 is 24, and my 1 is 25. that gives me my total amount of £250, which I will write on the answer line again, just so the examiner knows what I've done. Now, in order for the mark breakdown on this, you get 1 method mark for finding, let me get a different colour pen. You get a method mark for finding what one part is equal to. You get your second method mark for multiplying that by the ratio and getting the number of letters and number of packets. You get your third method mark for finding the price of the letters. You get your fourth method mark for finding the proportions, so the 2/3 and the 1/3, to give you the number of packets that you need. And so that's the 4 method marks, and then you get your final answer mark at the end, and that's your 5 marks. Question 8 is a nice question about straight line graphs. Questions about straight line graphs come in many different forms. This is an application of a straight line graph. So, water flows out of a cylindrical tank at a constant rate. A cylindrical tank is a cylinder. A cylinder is like a can or a tin. So, the fact that it comes out at a constant rate means that the line is going to be at a steady gradient all the way down. Constant means the same. The graph shows how the depth of the water in the tank varies with time. So I'm going to familiarise myself with the graph. There's the depth and there's the time. So this graph actually shows how the depth of the water changes as time goes on. Now, the first question wants me to work out the gradient of the straight line. The gradient is the slope. So what's the slope of our line doing? First thing I want to realise here is that my slope is going downhill. That means that my answer is going to be negative, whatever happens. So, to work out the gradient of a straight line, you do the gradient equals the rise over the run. And that is the change in its height divided by the change in its, width. So, what I need to do is find 2 whole value points on my graph that I can work with easily. There's one, that's where my line crosses the grid in a nice way. And then my other one is here, because that's where the line crosses the grid at a nice round number. Then what I do is I form a little triangle out of this to stop me making any mistakes. Then I work out what is the change in height. How have I gone from my line down to this point? Well, over here we can see that the depth is from 20 to 30. So that is 10. And because it's a downhill, it's negative 10. Because I've gone from 30 down to 20, so it's dropped by 10. Now I need to do my run. So how far across is this? It's in hours, and each big one is worth 1 hour. So each of these smaller sections is worth half an hour. So there's half an hour, 1 hour, 1.5 hours, 2 hours, 2.5 hours. So I'm going to call that 2.5. Now I can calculate the gradient of my slope. The rise was negative 10 divided by the run, which was 2.5. 10 divided by 2.5 equals 4. One of the items was negative, so it's going to be a negative 4. So my gradient is negative 4. If you had forgotten about the negative signs and you'd have found your gradient to be 4, just remember, downhill gradient is negative, so you would have to put the negative there. And for part B, it wants you to write down a practical interpretation of the value you worked out in part A. So let's think about what that 4 represents. The 4 represents the amount of depth in the tank after every hour. So because it's negative 4, it means that our depth is decreasing by 4 centimetres every hour. So that's my interpretation. Every hour, the depth in the tank and use the word decreases because it's a negative gradient. Decreases by 4 centimetres. And that's just a 3-mark question, and I think it's lovely. Question 9 is a lovely cumulative frequency question. So, the cumulative frequency graph shows information about the speeds of 60 cars on a motorway one Sunday morning. So, there's the frequency. Frequency means the number of. Okay, so the fact that there's 60 cars and there's a frequency of 60 is no coincidence. So the question wants us to use the graph to find an estimate for the median speed. Now, whenever you're asked to use a graph, you should be showing the examiner how we are using the graph. So, use the graph to find an estimate for the median speed. Now, we know that the median is the middle. And we know that there are 60 cars. Now, when we read in from a graph, we don't need to worry about accuracy, so we don't need to do the add 1 thing. I can just go ahead and straight away divide by 2, and that tells me to find the 30th car. So, here's my frequency, or my number of cars. I'm interested in the 30th one, because that's the middle. I get my ruler. I am showing the examiner that I'm using the graph. I draw a cross to my curve, and then I bounce it down to find out what it's worth. And it's given me a median of 120 kilometres per hour. And I've just written notes on my answer line. Don't you do that. So there's my final answer, 120 kilometres. Now, part B also uses the graph, so I'm going to keep this here. The speed limit on this motorway is 130 kilometres per hour. The traffic police say that more than 20% of cars travelling on the motorway break the speed limit. Comment on what the traffic police say. Now, what this is asking us is, first of all, does it show us that more than 20% are breaking the speed limit? Back to my graph. Now, I'm interested in the speed limit, which is 130 kilometres per hour. I'm going to show the examiner I'm using the graph. So there's my 130. I'm going to draw a line up and across. And I'm going to take that reading, which is 52 cars. So, the fact that it says 52 cars, don't make the mistake of thinking that 52 cars are breaking the speed limit, because it's actually this amount of cars that are breaking the speed limit. 52 cars are going under the speed limit because they're within this region. I'm only interested in the cars beyond this region. So there's 60 altogether, and 52 of them are doing the speed limit. So my first stage of working out is going to be to show that there are 60 cars altogether. 52 of them are doing less than the speed limit. That just leaves us with 8 cars that are over 130 kilometres. So that then gives me my first method mark. I've shown that I've used the graph. They are going to look for my lines on the graph. And I can get an answer mark for making the statement 8 cars are over 130. Now I've got to make a conclusion based on this compared to what the traffic police say. So the fact that there are 8 cars speeding out of 60 cars means that on my calculator I can do 8 divided by 60 equals 0.0. Oh, I've done 3. Sorry, it's 8 divided by 60 equals 0.13 recurring. So that is 13%. So 13% are speeding. So let's look again to double check what the traffic police say. The traffic police say that more than 20% of cars break the speed limit, and we've shown that it's only 13%. So the police are not correct because only 13% of cars break the speed limit, which is smaller than 20%. And that is where you're going to get your third answer mark for proving the police wrong. Now, part C starts down here, but make sure you do not miss out. Make sure you do not miss out the fact that this information belongs to part C. So for the 60 cars that we were looking at on this graph, so we're still referring back to this. For the 60 cars, the minimum speed was 97, the maximum was 138. Use the cumulative frequency graph. So again, they're asking us to use it. They want us to show that we're using it. Use the cumulative frequency graph and the information above to draw a box plot showing information about the speeds of cars. Now, to draw a box plot, I need, first of all, my minimum value. Then I need my lower quartile. Then I need my median. Then I need my upper quartile. Then I need my maximum. So the information above actually gave me that the minimum was 97 and the maximum was 138. I found out from part A that my median was 120. So that just leaves me to find my upper quartile and lower quartile. So here's my graph. That was my median, which was halfway. In order to find my lower quartile, I need to drop down to 1/4. So if a halfway was 30, my lower quartile is going to be down here at 15, because half of 30 is 15. So I draw across and I draw down, and that gives me 115. So that there is my lower quartile. So that was my 1/4 point. To find my upper quartile, I need to look for the 3/4 mark. So I can add 15 and 30 together, because that's 1/4 and 2/4, and that's going to give me 45, because that's my 3/4 mark. So from 45, I can draw it across and bounce it down. And that gives me 126. And that's my upper quartile. So I can go ahead and put these on my list. My lower quartile I found to be 115. My upper quartile I found to be 126. I can then go ahead and draw these into a box plot using a ruler. So my minimum was 97, 95, 96, 97, so that's there. My lower quartile is 115, 105, 110, 115 is here. I'm going to make the lines all the same length. My median's 120. My upper quartile is 126, that's 25, 26. And my maximum is 138. So there's 135, 6, 7, 8. Now I just need to draw my box in, which is the middle three values. So the 2 quartiles and the median. And then I join my extreme points up. And there's my box plot. Now that's a 3-mark question. You get 1 mark for having the minimum and maximum correct. you get the second mark for having the quartiles correct, and the third mark for getting the median correct. And you get 1 mark for having any one of them correct.